Look at compound events, the probability of compound events. And we start off by considering independent and then dependent events, and then we'll move to mutually exclusive and not mutually exclusive events. But a compound event is made up of two or more simple events, and this might also be called joint probability. Now, if a compound event is comprised of independent events, that's because the outcome of one event does not affect the outcome of the other. So they're completely independent. Thus, we call them independent events. So let's look at an example. They love to use marbles as their examples. Kids used to shoot marbles all the time. I don't even know if they sell marbles anymore. They're probably afraid some kid is going to choke on them. So we got a bag contains 6 black marbles, 9 blue marbles, 4 yellow marbles, and 2 green marbles. So first question I want to ask myself is, how many total marbles are there? Well, let's see, there's 6 black, and there's 9 blue, and there's 4 yellow, and there's 2 green. Let's see, so what do we got? 6 plus 9 is 15, plus 4 is 19, plus 2. So we got 21 marbles in the bag. Now, a marble is selected, replaced, and that word replaced is big, considering whether is this an independent or a dependent event. If I start off with 21 marbles and I draw one out, but then I put it back, how many marbles do I still have in the bag? Well, I'd have 21. And so therefore, that's what actually makes, in this example, the two we're looking at, makes them independent events. If I didn't replace the marble, then the outcome of the first event affects the outcome of the second event. But let's go on. A marble is selected, replaced, and a second marble is selected. Find each probability. Now, let's go to what is our formula, I guess I would say, for the probability of independent events. The first thing I got to do is this independent or dependent? And then if it's independent, then it is the probability of event A times the probability of event B. This is how I would determine the probability of independent compound events. So let's look. What's the probability of drawing a blue marble and then a green marble? And we're replacing the marble that we draw on the first draw. Well, let's see. We got 21 total marbles, and for the blue, there's 9. So the probability of getting a blue marble is 9 out of 21. That's the probability of event A. And if I replace that, well, then what's the probability of a green marble? Well, there's 2 green marbles. I replaced the marble, so there's still 21 in there. And so the probability of drawing a blue and a green after replacing the first draw is 9 over 21 times 2 over 21. So 9 times 2 is 18. What's 21 squared? 441. So the probability of doing an independent event of a blue and a green marble is 18 over 441. And I might just be curious, what's the percentage of that? Let's see, 18 divided by 441 is about 4.1%. All right, let's see. Now, got a little twist on this next one. Probability of not drawing a black marble. That's my first event, not drawing a black. Well, there's 21 total marbles. There's 6 black marbles. So the probability of not drawing a black marble is all the other marbles. Well, 21 minus 6 is 15. So there's 15 marbles that are not black. So the probability of event A is 15 over 21. We're replacing the marble back. And then it is, well, how many blue marbles? Well, there's 9 blue. So the probability of drawing a blue marble on the second event is 9 out of 21. And for this independent event, the probability of drawing first a not black and then a blue after replacing is 15 times 9, which is 135. And 21 times 21, we've already figured, that's 441. And what's the approximate percentage of that? Let's see, 135 divided by 441. And so that's approximately 31%. Or if I rounded it to the nearest tenth of a percent, I guess I could say it's 30.6%. All right, next up we're going to look at dependent events, where the outcome of the first event does affect the outcome of the second.